Alright guys, welcome back. We got another LeetCode today. Today we got subsets 2, grinding through all these backtracking problems. And this one looks like another one. So, let's get into it. So given an integer array nums that may contain duplicates, return all the possible subsets. Riveting stuff here. I think the catch on this problem is that nums might contain duplicates, which, to be honest, I don't know how that affects me, or at least the way that I solve this problem, because if we look at my tree here, like let's say nums is 1, 2, 2, 1, 2, 2. How I do these is I can make two choices at every index in the nums array. I can either like take that or I can not take that, and then I just update my pointer after that. Oh wow. So I either would go through and I'd take 1, 2, or I wouldn't. I'd just have 1, or I'd go through and I would take 2, or I would not, and I'd go through and I would do the whole thing. So 1, 2, 2, 1, 2, or I guess this also goes to 1, 2, this goes to 1. I mean also, and not include duplicates as 1, 2, 3, 4, 5, 6. So I guess you remove the duplicates. So I guess I couldn't do both of these. So maybe that's where the problem actually comes in. Because obviously, I mean, I could just like enumerate this whole tree and filter them at the end. But I don't think that's going to be performant enough to submit on this problem. Or it shouldn't be if the problem was well designed. But let's just try this. Let's try what I have here and see if I can just filter it at the end and see what happens there. So, what am I going to call this? Subsets is bang. We'll have subsets is bang. Boom. Helper, call it at 0. And return that. And then inside here we can have our two base cases. We can have what are our two base cases again? I think it's just one base case. If I is greater than or equal to lang nums, then I append it. I guess I have to append a copy. And I return. And in the other case, I either append nums I, recurse on I plus 1, and pop, or I do nothing. So I don't have to add or pop anything. So let's see what this gives me. Which it should give me just all the subsets, which it does. But you can see we have the duplicates in here, which is our main issue. So we can do a quick if subset not in subsets. So that'll get rid of all our duplicates. That is an O of, is it O of n check? I don't think so. But it's some check here. I mean, that's not a free operation. And also I have to enumerate the whole tree. But I'll just want to see if this is going to submit. Oh, what? I wasn't expecting a submit on wrong answer. What's going on here? 4, 4, 4, 4, I hit that. Which one am I not getting? What? 1, 4. Just 4. 4, 1. Do I have 1, 4, and 4, 1 in here or something? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which ones am I not catching? I have 4, 1, and 1, 4. Is that my issue? This one only has 1, 4. I see. Oh, that's because nums isn't sorted, so this will work for unsorted arrays, but I like to sort it first so it's more deterministic. Now this case should be fine, because I'm getting 4 and 1 and 1 and 4 because it's not sorted. Yeah, but if I sort it, then the 1 always comes before the 4 and I only get the 1, 4. A lot of 1s and 4s, but let's see if this submits. Oh, it does. Yeah, but it's it's really bad, which is about what I expected. I'm surprised it submitted at all. If I'm qualified to give LeetCode advice, I would say this shouldn't work, because I'm enumerating the whole tree, and I don't want to do that. Because I shouldn't have to recompute this here and here. It just looks inefficient. You might say, oh, it's just one time, but I'm sure this happens plenty of other times in this now horribly looking tree. I wonder if the best way is here. So I have duplicates, and right now what my tree is doing is either I select a number or I don't select a number. But if I don't select a number, like at that index, that same number could just show up later. So maybe the better thing is, like, my better choice to make is either select a number or don't select any occurrences of that number. So what I'm saying is I could set up like a while loop here on my not selection case, and go while nums I is the same as nums I plus 1, but I also have to catch the end, so while I is less than length of num I plus equals 1. I think it should work. Or at least, no, well, I need both of these to be true. And let's see what this does. List index out of range. I didn't do it right. So while I is... Oh, I guess I want that to be within, since that's the furthest element out I'm catching. Okay. So that works. Let's see if it submits and it's any faster. Nice. I mean, I guess it's not even the fastest. Do I not need this check anymore? I don't think I might not need this, since I'm now actually removing all the duplicates properly. Maybe this will make me faster. It'll remove that additional linear check. How's this look? Bang! Bang! Let's go. Let's go. Maybe I am starting to figure this out. As soon as I start thinking like this, sure to run into a problem that will humble me. And if you wonder how I figured this out so quickly, it's because I did a similar thing for this problem here. I'm following this guide, which is very good, and this took me a while to figure out. That's why you don't see a video on it. I record a video for all these, and if it's too long, I don't upload it. But when you're dealing with duplicates, the choice you want to make is not whether you want to add a number or not add a number. It's whether you want to take a number or not take any occurrence of that number. And if they're sorted, all the duplicate numbers will be adjacent to each other, so you can just skip them all like this on your not take any occurrence of that number case. But hopefully this was helpful, and I'll see you in the next video. Goodbye.